I'm Joel at rhythmschool.com. You're welcome to drop me an email if you have feedback about this or you want to talk with me about debugging or about Rhythm School or such. I'll be happy to talk with you. Brittany, of course, is from our admissions office, and she's going to be with us as well for most of the presentation. And we'll talk a little bit about Rhythm School at the end of the presentation. But what I want to talk about tonight with this, I want to talk about the fundamentals of debugging. What are some just like out of the gate things that can give us fewer bugs? And a reliable process where you can make progress as you debug. Talk about logging. I'll talk about using debuggers. I'll talk about how do we prevent bugs and how do you get better at debugging things. So let's dive in. But first, I want to turn the tables to you all for a second. I would love for you to take a moment and think about what kinds of bugs you've encountered. Because honestly, self-awareness of like, what are the kinds of things that I do wrong is your first important step in becoming a better debugger. And I'll open the floor for anyone who wants to be brave and tell us about the, is it a syntax problem? Was it, oh, I forgot that my for loop was still looping, or I didn't update my variable, or I didn't call my function? What are what are some of the kinds of bugs that you've seen? No shame, everyone. The act of coding is to create bugs, so all of us will have things here.
I have
Are,
any. Oh, go
Yeah,
ahead.
there are just enough people. I'm going to ask you if you can to raise your hand because we have enough people that I can't see all your faces during the presentation. Um, we've just kind of gone over the threshold for that. So if you wouldn't mind, just there's a little button at the bottom of the Zoom window. I am logged in as host, so I don't see the normal things, but I believe you have a button called reactions. Do you see that? Go ahead and click on that and click raise hand for me, please. Cecilia, please.
Thank you. One of the classic thing that I run into often that I expect something to be an object and it turns out it's an array and vice versa.
Great.
And yeah, that's an interesting one usually.
The thing that I am trying to work with is not what I thought it was. That's a whole family of things that can happen there. Absolutely awesome. That's a classic one. Is it Regard? Please.
yeah, regard. A bug that I usually run into is like I would refer to a variable and it tells me it's undefined. It's usually a spelling error, or I forget to use like the let or const because I've like also I've like learned some Python and like I mix up the syntax between Python and JavaScript. So I forget to declare the variable. Sometimes I just put the name of the variable and like assign it to something without using the let or const keyword.
That's a great one. For those that don't uh, understand what we're talking about with Python, in Python, you don't say var or let or such. You want to have a variable called x set to 50, you just say x equals 50. Um, and that can be, JavaScript will let you do that, but it will make a global variable, which is super easy to accidentally change in other places. And like, yeah, what is my variable set to and what's its scope? And some of you may have heard that term. Like, where does this variable have meaning? Is it just inside this function? Is it global throughout my program? Those are great things. Thank you, Regard. Jeff, welcome back. What have
Hi.
you?
Thanks. I was just going to say the classic is the array index off by one error, especially with jumping between languages and forgetting whether it's zero based or one based.
Yeah, there's a whole like the bug that Jeff is talking about is such a classic that it has a name for it, the off by one error, where you got all the way to the end and then one past the end, or you got almost all the way to the end, but not the final item. Like you were off by one in your math. And of course, you all, I assume at this point, if you're here, know that JavaScript begins the index of an array at 0, so that the first item, as us humans would call it, the first item is item at index 0. And so you will probably recognize code like this. I have some list of numbers, and I want to see go all the way to the end of my list of numbers, to the end, but not try to go beyond the end. You've probably written code like this. And a super, super easy whole class of bugs you can do. Now I've got a bug. Now I'm going all the way to the item at index 5. Sorry, 1 second, there's a siren testing. The joys of living in the city is I'm 2 blocks from a firehouse. This will take me all the way to the end of the array. If I have an array of 5 items, since we start counting at 0, the last item is index 4, not 5. There are lots of ways to fall into that off by 1 error, but that's a really classic one. Good one to meet the name of. Yeah, John, please.
First of all, we all know that was one of your cats, not a siren. But the bug that I find all the time is I'm trying to update a variable after a loop, and either the variable should be outside of that loop or it is outside and it should be inside.
Yeah, that's probably that same kind of class of a scope. Where is that variable name meaningful? I'll share with you probably the bug that the family of bugs that is 50% of the bugs that I've ever made. From when I started programming through yesterday. The line of code that I thought would run is not the line of code that ran. I didn't call my function. I meant to call my function. I didn't call my function. I thought the if condition would be true, and I would hit that line that, did whatever, said x equals 50, but my if condition wasn't true, and I didn't hit that line. So there's a whole family that for me also pops up a lot of like, it's not that there's a problem on the line of code, it's that I didn't get to that line of code. And the mental model that I had thought I would get there. You'll probably think of some other ones you've hit, but it can be instructive to think about the kind of bugs we make. So as we go, if you recognize some of the things that we'll talk about, see what things they can help you with. All right, let's dive into some early fundamental stuff. I'm going to lead with the best piece. The best thing I can teach you tonight is to have a process about debugging. When you first start learning coding, it's very easy for your process to be just keep changing things until it works. And no shame, that often works. Oh, maybe I should try making X false. Maybe I should try making that plus plus, not plus equals. Like just trying something and seeing if it improves it. But unfortunately, you hit a really hard ceiling with that. When you first start learning programming, your programs are only 5, 10 lines long, maybe 1 function, 2 functions. You don't have a lot of code because you're learning. You're still new with it. But with a 10-line long program, you can change everything. You can try everything. You can systematically be like, let's make it -1, let's make it +1, let's make it -2, let's, it's possible to change all the variables. And then when you find that it works, stop. Unfortunately, if you keep that as your process, which is really easy to accidentally do, just try things and see if it works. You hit this ceiling that with the 20 long line program, it takes about 5 times as long to try all the things. And with a 55,000 line long program, which is the size of the program that I was working on this week with some friends, it's impossible. And that's not even an unusually big code base. You hit this ceiling where you can't, that process won't work anymore. And so the first thing I want to talk with us is reframing the process. Put on your lab coats and position yourself not as, oh no, I'm a programmer with a bug, but I'm a scientist with an experiment. We want to use the scientific process here. And the first thing I want to do is I want to observe really carefully what's happening. I usually want to do things twice to find out if this bug is stable. If I have a bug with my game here, where when I click a corner piece, if I click it, it should swap these 3 cells. But if it's only lighting up 2 cells, first thing I want to do is that stable? Does it continue to be that? Or is there some other confounding thing I haven't thought of? Oh, it's an even move, it works, an odd move, it doesn't. Do lots of observation before you make any changes. Let's say I have this bug that sometimes when I click a corner, it doesn't flip the 3 cells here. What's something else I should try? Not even looking at the code, not changing anything. You know, I've clicked this top left cell and sometimes it works, sometimes it doesn't. I'm not sure why. What impulse might be another thing for us to observe? What's another thing that you might want to test here, just in terms of interacting with the browser?
Try another corner.
Try another corner. Absolutely. It may or may not be that that's the case, but I think that's a great impulse. Maybe try a cell that's on the same row, but over by 1. On the same column, but down by 1 or such. Spend a few minutes getting your observations down. Again, when you have more code, starting with the code is not going to be your best solution forward. Get a good, solid set of observations. And then make a hypothesis. When I click on corners, it sometimes works and sometimes doesn't. And it's happened on all of the corners. So my hypothesis is the code that looks and decides what parts to flip probably isn't doing the right things when cells above and cells below don't work. But remember, with your observation, think like a scientist here. I want to just not prove like, oh, look, when I click the corners, it sometimes works, it sometimes doesn't. Answer that question, if I keep clicking non-corners, does it always work? So check out your hypothesis. Do a negative test here. Oh, all the non-corner pieces never exhibit that problem. Just the corner pieces do. And then we're ready to take a look at the code. But force yourself to come up with a hypothesis. Unfortunately, things that are tempting are, and you may have done these things, I certainly have, and I find myself still doing them even though I've learned better. I'll just read the code and see if anything looks wrong. Again, that works okay in a program that's 7 lines long, but it doesn't scale. Come up with a hypothesis you can check for and prove. And then change one thing. Save your work, try again. If that doesn't fix it, what you want to be really careful of, don't try multiple things. So I changed line 7. I changed that from +1 to -1, and that didn't fix the problem. Make sure that you undo that work on line 7. Because I don't want to then, oh, let me now also change y. Let me, you want to have one hypothesis at a time. Coming up with an organized process like this can really help you out. There's a fun t-shirt that I've seen people wear at programming conferences that says, debugging your code is like being the detective in a murder mystery where you're also the killer. Like, you're in this interesting headspace of like, you have a little bit of inside knowledge of what's going on, and you have impulses of what you can try changing. But unfortunately, if you don't know what the bug is yet, changing things can give you 2 bugs or 3 bugs instead of the first one. In particular, as your code gets longer, it's really dangerous to try changing things and then change something else and then change something else. And then you won't know how to reset things to where you started. So high level, we're going to use this process to kind of frame things throughout. Let's dive in and look at some of the tools that can help us with this. The very first thing is an absolute gimme. It's a super easy piece. You may or may not know about this, but if you don't know about this, this is going to help you. JavaScript is a 30-year-old language. And like any 30-year-old language, it has some pretty crummy edges to it. You know, things change over time. And JavaScript was originally developed for different kinds of things than we use it for these days. And so JavaScript, the original design, is super loosey-goosey, super tolerant. You all have observed some of these. If I look in an array for an index that doesn't exist, most programming languages throw an error. JavaScript just returns undefined. JavaScript is a really forgiving language in good and bad ways. About 20 years into JavaScript, they recognize that it's probably a little too forgiving on some things, and they added what in JavaScript is called strict mode. Strict mode gets rid of a whole class of just the language should have never let you do this, and now it won't. So the very, very first line of your JavaScript file should be exactly this. The quotes matter, the semicolon matters. And so I'll come here to my JavaScript file. Just move my windows around so I can see that JavaScript. And I want to make sure that I have that line first. It looks like it's just a string. It is just a string. It's not going to print anything out. But if the very, very first line of your file is this exact string, capitalization matters, spelling matters, you got to get it right. Then JavaScript goes into what it calls strict mode. And in strict mode, there are a bunch of things it won't let us do anymore. And one of those is something that was a bug for that you all brought up, which is in JavaScript, if you just start talking about a variable that doesn't exist, JavaScript normally lets you do that. I believe this may have been the one that you mentioned, Cecilia. JavaScript will just make a global variable called z and set it to 50. But in strict mode, it won't do that. It'll throw a syntax error. If you want to have a global variable, create it in the global scope. That doesn't throw an error. That's perfectly good. There's some other silly things that strict mode fixes for us, things that just never should have been in the language. If you use the same parameter twice in a function, if you have ambiguity about whether a semicolon should be at the end of a line, there are a bunch of really small things. None of them are things that you'd ever want. They're just things they figured out. Halfway through the life of JavaScript, we shouldn't have designed the language this way. And that will get rid of a whole bunch of bugs for you. It doesn't get rid of the bugs, of course, but it changes them from a mysterious thing to scratch your head about to you have a syntax error, which is a lot easier to figure out what's going on. It makes a bunch of things that it would otherwise ignore. Now throw in an obvious error. It's just a gimme. If that's a new one for you, just put it at the top of each file. As you get more advanced in JavaScript, you're more likely to write code inside of something we won't talk much about tonight called classes. Code inside classes already runs in strict mode. As you get more advanced with JavaScript, you'll learn how to work in what are called ECMAScript modules. Code in those already runs strict mode. All the things that have been added to JavaScript in the past 10 years already put you in strict mode because they're like, it's such a good idea that of course you should be in it. But for backwards compatibility, they can't make it the default for the language. So it's totally what you should be using. Just make it the first line of your code base. The second big thing that can help you out is to make a diagram like this. And there's a name for this kind of diagram. It's called a call graph. A call graph is a graphic representation of the functions in your program and which one calls which. So When the program starts, it calls add click listener, it calls setup random board, setup random board calls random number, setup random board calls so on and so forth. One of the most important things to have in your head is you have bugs, if you don't have bugs, if you want to not have bugs, is do you have a solid representation of where you are? I'm here in toggle cell and neighbors. I put a console log inside toggle cell and neighbors that says x equals whatever it is. How did I get here? What are the places that call this? Having a drawing like this lets me see that answer really easily. Setup random board calls this, handle cell click calls this. Making a call graph like this can give you that stable idea of where am I, how did I get here? And as we talk more about logging, it also helps me see bugs. So if setup random board doesn't, if when I call this function and it doesn't console log that I'm here and it doesn't console log that I'm here, then that can help me find my class of bugs. The line of code that I thought was running did not actually run. Did I call the function? Did I enter that piece? Really fancy editors, as you get more advanced and your company pays for you to get, $500 editors, they'll actually draw this drawing for you based on looking at your functions. If you're using a free editor like VS Code, it's not going to do this for you, but grab yourself a pencil. This is such a helpful thing to have a drawing of. And this is in fact the call graph for the lights out game. You may have guessed that. Just look at the names of some of these functions. And there were some things that might have been easy for me to forget without this, that I think of when I click a cell that it's going to flip the cell, but also when the game starts and it sets up a random board, that also flips some cells. I'll hit refresh for so we can see that, because of course the game starts off with some random things flipped and unflipped. And call graphs can really help me remember what the flow should be. So, highly recommended. Yeah, John, please.
Joel, this sounds like a silly question, but when you're designing or creating your call graphs, how do you do that? Are you just walking through line by line? If this, then I go here and then draw that, and then what if I went the other path, like you're reading through a choose your own adventure book?
Yeah. That heads John into stuff that's a little beyond the scope of what I can talk comprehensively about tonight. But I'm happy to take a few steps in that direction of, do I design the program before I start programming? Do I start programming and then document what I've done? And that's a big, broad question. I'll tell you a little bit about how my flow is. Over time, doing it a lot has really, really taught me that more time planning up front is always going to cost me less time overall. So I am definitely, before I touch a keyboard, I'm going to grab a piece of graph paper and sit on a sofa and draw some things. And that can take a while for that to be where we start off, and it's really tempting to start typing. And I know people who do very good work, thinking as they type. But for me, I'm much more of a planner first for my code. And so I will typically make this drawing before I have code, because I'm already thinking about what are the things I need to do. You may not be in that place, or that may not be the right thing for you, or you might be looking at a program that, it's already written and your job is to find the bug. You don't have that chance. But in which case, then go through the code and make yourself a drawing like this. It also helps a lot, John, with if you just give yourself the goal of read the code to find the bug, there isn't really anything for your brain to do besides hoping that you randomly notice something out of place. Whereas reading through the code to find all the function calls to update this drawing will both give you the drawing and also make it more likely that you might even notice that missing comma or such, because it's a much more interesting and engaged thing for you to do rather than just kind of repeated prey, as it were. So when you make the drawing, it sort of depends how you work. I myself make it very early on in the process. That helps me. Does that give you some ideas?
Yes, thank you for the insight. Appreciate it.
You're very welcome. I'm showing you a little computer drawn version here because I have terrible handwriting, but the best thing I'll convince you is, oh my God, don't try and draw this in a program. If you're like me, you'll spend 7 minutes then adjusting all the boxes and lining up the arrows and adding drop shadow. Just there's a reason why programmers have whiteboard markers and why I am never more than a foot away from a sheet of graph paper on my desk and things like that. Just make yourself a drawing. If you don't have a whiteboard at home, you have windows at your house and mirrors at your house, and whiteboard markers work great on those as well. So sometimes it's helpful for me to be standing up and moving around drawing things. So I have a whiteboard here in my office, but if you don't, feel free to do some whiteboarding on your glass shower wall. Works just fine. Next thing I want to talk about is logging. And I know it sounds obvious, but I want to underline it for us here. This is one of the smartest and most accomplished programmers in existence, Brian Kernighan, one of the primary authors of Unix. The most effective debugging tool is still careful thought, coupled with judiciously placed print statements console log, as we know them. And it can be really easy when you're a beginner to assume that console logs are a shameful thing that beginners do and that real programmers don't use them. That is absolutely 1000% false. It can also be really easy when you're beginning to put lots of console logs in and you're not sure where they should go, and you end up putting a lot of them there, and then you forget what they all do, and then you start deleting them, and then you have to retype them a moment later when your bug reappears. So let's tackle good ways to log things. First thing is, and I'm going to switch here to my browser for a sec, turn on my console. Sorry, just so I can see the debug console. Alrighty. Of course, you know console log. I'm sure if you're here, you know console log. Some things to know. Console log can take multiple arguments. So I don't have to give it one argument. I can give it as many arguments as I want. It will just separate them by spaces. That can be particularly helpful because otherwise, if you don't remember that, let me just create a variable here. Create a variable without a syntax error. Otherwise, if I don't remember that, you can end up doing that. Where if I'm going to give console log one string, but I'm going to build it up by concatenating, by adding things to the string. And that works okay. But let's say that what I log isn't a simple number, it's an array. That totally doesn't look right. Let's say that it was an object. Yes, it's an object. That's not very helpful. So the first thing, and again, I apologize if this is a really obvious thing to a bunch of you, but console log takes multiple arguments. There's a fancy name for a function that takes an arbitrary number of arguments. That function is called variadic. It varies in how many arguments it can take, and console log is one of those functions. So if you want to console log out what x is, get used to doing it like this. Give you here just a representation. It's a variadic function. It takes multiple arguments. But in addition to console log, there's also console warn. It doesn't crash my program. It doesn't break anything. What does it do? It puts it in yellow. Because very often you may find when you add lots of console log statements, you'll want to know which ones are really important. If you don't know console warn, same thing with yellow background. So that's helpful for me. Sometimes the console logs around the bug that I'm currently chasing, I'll change to console warns. One of the nice things of using both log and warn is you can decide which ones you want to see. So I'm clicking here this little all levels. Your browser might show default levels, or if you've turned them all on, it'll say all levels. But I can turn off things that I don't want to see and only show the warnings, not all of the other console logs that I had. So console log can be useful because it shows up more easily and I can hide the things that are below the levels, which is nice. And then there's console assert. Have any of you ever used console assert? I think it's a super under talked about one. Awesome. Well, you'll learn something neat. Console assert takes at least two things. It takes a condition and a message. But just like console log, you can have multiple messages. You can give as many arguments as you want. So X right now is 42. If X is greater than 30, my message should say hi, I imagine. This condition here, oh, sorry, this is console log. That's why I'm seeing it. Let me change that to my assert. Okay. This will make more sense. It didn't print anything because I first asserted if X is greater than 30, we're okay. You don't need to say anything. Let me set X down to 10. Hit that same statement, and now I get assertion failed. Oh no, X is too low. And again, if I want to show more things, I can add more arguments and it will show me what X is as well. Console asserts are really useful because they're not quite formal software testing, but they're a really easy way to test things. It's built into the language. And very often, rather than drowning in a whole bunch of console logs every time through your loop, you just want to get a warning if I go past 10, or if this is an empty string, or if this is undefined. Something to note is it doesn't actually crash your program. It looks like it, it's got a red box, it looks the same way as an actual error, but it doesn't crash my program. But it definitely jumps out and tells me that something that I assumed shouldn't happen has happened. That's a really helpful one. It's not as commonly taught as console log. I think it's even more useful in many cases. It's like a smart console log. Yeah, Brittany, please.
We had a question in the chat from Larry. He said, is log using commas more performant than string literals or templates? Do string literals or templates concat behind the hood?
Well, a string literal is concatenation just with different syntax without the plus sign. The performance of them is one takes 1.1 nanosecond, one takes 1.2 nanosecond, and it'll change depending on what the weather is outside. It's there's no concern about performance for them. Why you'd want to give it multiple arguments rather than concatenating it, which probably, I will guess, is again the one that's probably 1.1 nanoseconds, probably a little bit faster, but the performance isn't the concern. It's just that the clarity of it'll show you what it actually is rather than turning it into a string. And we saw how arrays don't show anything if they're empty. Objects just always say object. So you want to give it multiple arguments rather than concatenating either with a plus sign or with the template, the template literal, which is the same thing. It's just a way to make a string out of different expressions. I hope that helps you out. Thank you, Brittany. What should you log? I'll introduce a term for us here. Engineers will talk about instrumenting your code. When you instrument code, you're adding stuff to the code that allows you to figure out what's happening. If you ever feel bad about console.log, just remind yourself that professional engineers call it instrumenting, and they get paid a lot to instrument their code. Like, you can feel really good about this. Adding console logs before you have a bug is probably the most helpful thing you can do with log. And I'll show you here. I've already added them so that we'd have a chance to see this. At the top of every one of my functions, I have a console log that has the name of the function and what are the parameters passed to my function. So my function random number here takes an upper range. My console log says random number upper range. I would say this is instrumenting my code. It's adding that evidence of what's happening. And let me hit refresh and I'll play lights out for a second and you can see the kinds of things that it's pushing out. I always have the function name because otherwise you'll never remember what this console log is. You don't need any kind of fancy ASCII art, just give yourself the name of the function. Click cell, and I can see exactly what happens. This is really helpful because when I have that call graph, and I'm looking at the call graph, and I'm looking at the logs, I can see if things are missing. Hey, wait a minute. It never called my function. How do I know? Because if it did call my function, I would see the log statement I have at the top of my function. This is even more important as you get more advanced. Later on, you may learn about how to use React, which is a popular JavaScript library, which is super cool and does a lot of things for you. And it is incredibly difficult to figure out why it didn't render something for you because it didn't call your component because of some deeply obscure thing that you forgot. Oh my God, put a print statement at the top of all of your components saying, I got here. You know that I got here. This is probably the most helpful thing that I do with console.log. Instrument each of my functions. Did I get to this line of code? And what was passed to it? Let's look at one last thing about logging. Let me, so I've got my X variable, which is 40. Nope, I hit refresh. So let me make an X variable here. I've got my X variable, which is a number. I'll console log my function. I'll console log my number. Let me make X a string instead. I'll console log my func and my X, and they look the same. Have any of you ever had a bug where the type of this thing is not the type I expected it to be? JavaScript is notorious for this one. I want to add 1 to x plus 1. I don't get 43, I get 421 because JavaScript helpfully decides that I wanted to concatenate two strings and turns that number into a string. Unfortunately, console.log doesn't tell us what type something is. But I'll show you my favorite little hacky trick for this. Don't just console log your variables. Put them in an object. Now you may not know this, but in JavaScript, if you want to make an object where the key name is the exact name of a variable that you want to be the value of that key, instead of having to say x colon x, I can just say x. You may or may not know that. It's called the object literal shorthand. That will just create an object with a key of x set to the value of x. What does this give me that's super helpful? It tells me that it's x, and it shows me that it's a string. I want to show both of my variables. Now I can see them both, and I can really, really clearly see which one is which one is a string, which one is an object. It's a little bit of a hack, but it's just because that's the nature of how console.log shows an object. If you just console.log an object, it'll show it to you with those key descriptors and the actual type. Anything else about logging things? First half of our big strategy, figure out if the control flow, if how things move through the program is what it should be. And how do we instrument it? How do we put that in before I even have a bug? Okay. I'll offer you some reassurance before I move on from logging. Everyone console logs. Again, there's no shame. If you look on the internet, you'll see people that are like, oh my God, don't use console log. You know, you only get people looking at your YouTube if you complain about things, if you say outrageous things. I'll tell you, the person who's the primary author of Unix also agrees that this is a super effective way to debug things. And even though I'm going to talk about fancy debuggers, and I'm going to show you a fancy debugger, I only break them out when I need to. Starting off with console log is a great, easy way to tell me where I am in the program. And I want to tell you that so you don't delete. It's really easy to add console logs and then delete them, and then the bug comes back, and then you add them back, and then you delete them, and then you comment them out, and then it's that sense of, I should know what's being logged if my program is working. As I work on this program, I'll start to know what should happen here. And if I keep deleting logs and adding them and commenting them out and re-adding them, I won't have that clear of a mental model. So if your console logs are useful, as they should be, keep them in forever. We tell students in our main program, of course, turn in your code with your console logs in it. We know you have them. It's silly to remove them. Ultimately, when you're going to put things in production for real, as a professional, you run a program that itself takes out your comments. But doing that as a human is a fool's errand. They're useful, keep them in, keep them stable. Keep things instrumented. Okay, let's take a look at using a debugger. So I'm going to show us two ways to get to the JavaScript debugger. One is using the JavaScript debugger in a browser. So here I've got this browser-based game. I'm running the game, of course, in my browser. I'm running the JavaScript, loaded by this HTML page. And I can use the debugger here directly in my browser. So in the Sources tab, once you turn on, of course, the JavaScript dev console, in the Sources tab, it'll show me all of the files that it got from the server, including my JavaScript file. This is the JavaScript that the server sent me, or in my case, there's no server. I just opened up my HTML file, but what's on disk. And I can use the debugger, and if you don't know what I mean by say use a debugger, just hold on for 1 sec, because when we start doing it, it'll be much more visually evident. But I can use the debugger either if I know what line I want to stop at, I can just type the word debugger. Now, if I can't save this. This is just in my browser, so I'm not changing my real program. And if I hit refresh, that goes away. If I always know that I want to stop at a line, I can just put that in my editor. Hit refresh, and it will definitely, where's that? toggle cell and neighbor. So to the same thing I am editing. Sec. No, sorry. One sec, team. Let me to you all are observing another classic bug of mine, which is the file that I just edited is not the file that is the one that's actually being run. And I will tell you that one of the absolute best things you can do. One sec, let me quit my VS Code and open up the ones I'm actually looking at here. What's a good debugging lecture where the person presenting doesn't have a bug? There we go. There is a tremendous amount of value for the console logs that you put here, because they also tell us things like, is this the file that I just edited? And I'll tell you that one of the most helpful console logs I ever add, going back to console logs, is the, if I save this and I hit refresh, do I see that message? If not, I am editing the wrong file. You may have not hit that bug yourself, but you will one day, and that can save you a good half day of effort. Okay, let's put my debugger in here. Hit refresh, and of course we'll see that. And whenever the code hits line debugger, it stopped running my program. Paused in debugger. So my program is running except that it stopped. And I can look at the state of my program. And there are a bunch of things here that I'll wave us towards. I can see all of my variables. They're under this section called scope. And it organizes my variable by their scope. Some of you may understand what I mean by that. That might be a new term for some of you, but the variables that are inside of my function, the variables that are set at the top of my file, the variables that I get from JavaScript or that I have set as a global variable in some interesting way or such. You may need to open up these three different categories, and it's possible but unlikely that you'll have a fourth one called closure. You may need to open up these different scopes to find the variable you want. And I can see what X and Y are equal to, and I can see what script difficulty is equal to. So I can see what all of my variables are right here at this line of code. But I can also change them. I just double clicked on that, and I'll change it to 4. And now in a moment, when I say keep running my code, X will be 4. That can be really helpful. Oh, I think I found the bug, but rather than having to save, refresh, make the first 7 moves, blah, blah, like I can just change it right now and then keep running. Again, just double click on it. Other things this helps me with, when it closes up some of these sections, it shows me my call stack. I suspect one or two of you have met this term call stack before. Is anyone feeling brave enough to offer us an explanation of what a call stack is? Yeah, John, go for it.
Okay.
Oh, go ahead, whoever was going to talk, sorry.
Fight amongst yourselves.
You had the hand raised. I didn't. Go ahead.
Oh, no worries. My understanding is something in the world of you're in the environment of one of the functions until it gets taken off the stack, and then you're in another environment that you were in previously if it's below?
Call stack is a fancy term for where am I and how did I get here? Function A called function B, which called function C, which called the function that you're stopped in. And you'll see A at the bottom, B above it, C above it, your function at the top. So you start reading it from the bottom. What was the very first function that was called? What did it call? Above that, what did it call? Above that, until of course where you are. And so I'm here in toggle cell and neighbors, and I got here from setup random board from line 110 on setup random board. So I can see how I got to where I am. That's super useful because toggle cell and neighbors, if we think back to that call graph we saw briefly, is actually called from two different places. And I might be absolutely thinking I got it when I clicked, that I got it here and I'm really studying, but that's not how you got here. All your assumptions were wrong. So how did I get here? Super, super useful. But there's one more magic trick up our sleeve. I can click on setup random board, and I haven't changed what my code is doing. I haven't made it run my code or do anything, but now it's going to show me all the variables in setup random board where I was. Oh, I is a variable here in setup random board. I is currently equal to 0. And then I called toggle cell and neighbors. Click on toggle cell and neighbors. Now I'm seeing all my variables here. So I'm not even really like running my code any more than it was. It still stopped at that debugger line, but I'm able to look at what all my variables are in that first function that ran. What were my variables set to? When it ran my second function, click on the second function, see what my variables are inside that second function, and I'll see where I am, how I got here, and what all those variables are. This is the call stack part. All right, I'm going to come back to toggle cell and neighbors, which is where I actually stopped. Oh, I'm sorry, Jeff, please go ahead.
I just had a question. Which browser are you using? Web browser?
I'm using Chrome here.
Okay.
All of these features
And
will be the same, but look like the UI looks different if you were in Firefox or something else. But they all have a debugger and they all have the same kinds of features. But I'm in Chrome here, Jeff.
okay, I was just wondering if Firefox has
Yeah.
the same stack, call stack.
Yeah, it has the same thing. It's just it's colored differently. Same.
Okay, thank you.
Of course. Firefox is an awesome browser, and we should all try less corporate stuff. All right. Other things I can do here is I can watch my code run. Now it's stopped here. Notice it's lit up in yellow. I am stopped here. My program has frozen. But I have these buttons. And this button, the one that looks like a little play button on like a cassette tape, resume running my script. It'll go back to running my code. But if it hits that debugger line again, it'll stop there. So I just ran like 30 lines of code, and then it got back to toggle cell and neighbors, and then it stopped again. Or I'll hit refresh or I'll just click a cell because that'll also ultimately hit my breakpoint. Or instead of just running my script, I can run it line by line. Step over next function call. This is the little kind of rainbow arc over the dot. Watch what happens here. I'll click that, and now my program goes to the next line. It hasn't yet run line 28. It has not run it yet, but it's about to. Now, what's my hypothesis? If my hypothesis is that this function has a problem, I don't really need to study all of this code. I want it to run, but I don't want to have to manually watch that. Step over next function call. We'll call that function, run all the call, that whatever code was that that function call here on line 28 did, and stop on the next line. Run line 29, which of course involves calling a function and doing whatever that needs to do, and go to the next line. That's what the arc over the circle. The other option is the arrow pointing downward. And that says run the next line, but if that next line calls a function, go into that function and make you look line by line at what that function's doing. So watch what's different. I haven't yet run line 30. I'll click that arrow pointing downward, and now I'm inside toggle cell. And I can go to the next line, go to the next line, I can go to the next line. Both of these are going to be the same if you don't actually have a function call on a line. But now I'm watching all the code inside toggle cell run. I get to the end, I say go to next, and I'll pop back up here. And then I can make that same choice. Do I want to just jump to the next line and not have to study what happens inside of the function call? Or do I want to step in and watch step by step? There are some other options, and I won't talk about them because I don't want to drive you crazy with a bunch of new stuff. You can dig into step out and continue later on. But these three will give you 90% of what you want for the debugger. Run until the next time I hit a line debugger. Step over the next line, don't bother me with the details. Run the next line, or run the current line, but then take me into any function calls so I can study what happens there. And as I do that, I have all my usual abilities to go and look at my stack and see what the variables were, to look at my variables, to change my variables. How did I get here? Well, if I know that I have a bug in this function and I'm already in my editor, I can type the word debugger. Other ways I can do it, I can go to sources and I can type the word debugger here. Or if you're already here in the browser, often easier is just click on a line number. When I click on a line number, it'll give me this little blue indication. This is called a breakpoint, and it means it will stop here. So the next time that my code runs and it would have gotten here, it will stop. I'll click on a cell. Oh, look, clicking on a cell called handle cell click, which called toggle cell and neighbors, which called toggle cell. And I have a breakpoint here in toggle cell. And I can go back and look at what were my variables inside handle cell click. What were my variables inside toggle cell and neighbors? What was toggle cell called with? And again, I can step through that code if need be. How do I actually use this? I use it quite a lot when I hit problems that instrumenting my code doesn't solve, where I'm like, I believe that my function is being called, but I still don't understand why it's going wrong inside that function. I sometimes do stuff through my code, and that's kind of the sexy, really cool part. You're watching it run line by line. But honestly, probably the thing that helps me out the most is just when it stops, look around for a moment. Wait a minute, Z should never be equal to a string. Wait a minute, you weren't supposed to be called by, like often I actually just find like the looking around really really helps on stick me. But if you then you can watch it run line by line. Questions about that, friends? Alrighty, I'm doing this here in Chrome, and I think this is the best, easiest, most reliable way to do this. But I will show you a way where we can do it directly in in your editor. If you're using VS Code, which most people will because it's a nice editor and it's free. But you can do this directly in VS Code, but I'll warn you, it can be a little bit flaky. So don't forget about doing it in the browser. I want to edit my web application. I've opened up my web application here in VS Code. There's the little button that has a bug and an arrow called Run and Debug. And if I hit that, the Run and Debug button will pop up a menu of how do you want to debug things. And I want to pick Web App Chrome. Jeff, you can install an extension which will give you Web App Firefox, or you can install Chrome. It can work with either. But Chrome is built in to it. Firefox is not. Okay. Now it's opened up a window. You don't see this window. Give me 1 sec while I share a new window from Zoom. One sec, friends. Okay, so it just opened up a new Chrome window for me. And this Chrome window is connected to my debugger. So here in my editor, I'll see all my log messages appearing, same console log messages that I would appear. And I can go to my JavaScript file. And I can click to add those breakpoints. And then when I come to the place where I've set the breakpoint, click on a cell, it'll stop here. And I have all of the same things I can do. It's the same debugger. I'll have the same call stack. I can look at my variables. I can double click on my variables. I have the same continue execution, step over, step into. So it is the same debugger. It looks a little bit different visually, but it's the same kind of thing. And I can do it inside of my browser, inside of my editor, excuse me. It's nice to be in your editor. This is appealing. I'll just warn you that it's a little finicky with its setup, and so there are times when you'll set a breakpoint and it doesn't stop and you have to quit VS Code and load VS Code. So feel free to try it out, but don't forget about doing it in the browser because that is rock solid. It's just a lot simpler for everything to line up correctly. After all, the browser is what's really running your code when you're building a web app, so you'll have a more reliable experience in debugging here. But what I did to get this in my VS Code from the top, I'm just here looking at my HTML file. Click the little bug arrow, run and debug. And when you first click that, it should show me the run and debug button. And then it just opened up, you won't see it, but it opened up a window in it opened up a new window of Chrome. And that window of Chrome stopped because I had a breakpoint right here. And then I can do the same kinds of things here that I can do in the browser. I'll switch and remind us the way I got to this in the browser. Return to my real browser window here. Okay, you should see my normal browser now. the way I got to it in the browser is either just edit my code and type the word debugger, or go under sources and type the word debugger, or even use your click to get a breakpoint. Those are the things I want to show you about the debugger. There's a lot more there as you continue to learn and get, write more complex things. There are more complex things you'll discover. I'll give you just a little bit of a sense of what you can look forward to learning about. You can have what's called a conditional breakpoint, where you tell it something like, when x is greater than 50, stop running my code, because that's the only case that I really want to study. So you can learn how to do that kind of feature. You can also dig around and find when certain listeners, so you clicked on things, get called, stop on any click. So you can dig onto the event listeners that you've registered for things. But that's more advanced stuff. Start off with get it to stop and learn how to look around. Look at your variables under scope and look at your call stack. Okay. And that's how to run the debugger, both in your browser and in VS Code. Those are the big tool things. I just want to talk for a moment about how do you get better? How do you avoid bugs? What can you do to learn more? So, number one bug that students make at Rithm all the time, and you really, you want to work on this. Make sure your code is doing exactly what you were thinking in your head. And let me give you a really clear example here. I want to do something if x is not equal to 0. Is this code going to work? What do you think? I mean, if x is equal to 42, 42 is not, if you've heard the JavaScript term, falsy. 42 is truthy. Any non-zero number is truthy. And if I just compare it with an if condition, absolutely, this will work. If I want to print something out only if it's equal to 0, all right, x is equal to 0. 0 is falsy, not x. It will enter my if condition here. But there are a whole bunch of other things that will cause this if block to run. What else could cause me to end up in this console log besides x being 0? Anyone think of anything?
X being like null.
Undefined, 0, not a number. There are a whole bunch of empty string, a whole bunch of other things that could end up here. The number one thing I want to tell you is always write your code explicitly matching what was in your head. This will get rid of so many subtle bugs in your code. It's sort of an obvious thing, write the code to do what you mean, but it can be really easy because JavaScript offers us all of these tempting, like, you can just check for falsiness, and you can just check for falsiness, but now I'll enter this if block if it were null. Thank you, Rocket. Or any one of those other things. Another common one I see people do, a little bit more subtle. I want to find out, I've got some object of fruits. Apple is red and berry is blue. And I want to find out if cherry is in my object. All right, so if fruits cherry. But I've got a subtle bug. Maybe, I mean, it may or may not cause a problem, but I've got a gap between what was in my head and what I actually wrote. This says, go and find the value of the key cherry, and then decide if it's truthy. I have cherry in my object, but I won't enter my if condition because the value of the key, the value of the key cherry is one of those things that JavaScript considers falsy, an empty string. Don't worry if you don't know the syntax, but if you don't know the syntax, you might want to take note of it. This is the way in JavaScript that I really say declaratively, is this key in this object? Yes or no? Not, is it truthy? Is it falsy? Get the value. This is how I can say, is this in the object? And these two examples there's a whole bunch of places that you can think about this. You write a line of code, look away for a sec, think what you were thinking in your head, go look and see if the code expresses that clearly. Don't take any shortcuts. Don't take any like, oh yeah, it'll be falsy because it'll either be 0 or a string, like be explicit in your coding is the best way that I've learned to have fewer bugs. Just be really, really honest. Is the line of code as I wrote it exactly what I was saying in my head? And giving yourself an honesty check there can really help you. Particularly because JavaScript is so friendly and it's so like, oh, you can just check for truthiness and we'll just return undefined. And so there's just so much wiggle room that you can fall into here that a lot of other languages, are like error, you can't do that, you can't do that. Whereas, so like really, really, you have to be even more explicit in your head with JavaScript. I'll leave us off with another quote from Brian Kernighan, which I just love this one. Everyone knows that debugging is twice as hard as writing a program in the first place. If you're as clever as you can be when you write it, how will you ever debug it? I think there's so much wisdom here. I think about this one so much. When I get all super clever in my code, and I'm so, oh wow, I did that in 2 lines, and it's so cool and clever, and I feel so smart. And that is always the place that 6 months later, I'm pulling my hair out about. And I think you don't have to use new syntax. You don't have to worry about performance unless you have to worry about performance, which honestly, as you'll learn, usually you think about that once with your algorithm, not with your line by line code. That's a fool's errand. That keeping your approach simple, being scrupulously honest. Is this line of code expressing what was clearly in my head? Instrumenting your code, put in those console log statements and have a call graph so you can see if it goes through your program the way you expected it to. And get comfortable with using a debugger when you have the really hard problems where you do want to look at it. What exactly is everything equal to on this line? And those are things I want to talk about with this. The piece that I'll offer you on, and you may find as you think more about this that you'll notice you're agreeing, is that we make the same kind of bugs again and again. Like we all have our own kind of bug. You always forget to make sure that things are numbers and you end up adding strings together thinking they were numbers. That's your bug. And it's kind of, the same sort of thing of like, if I always look in the left rear view mirror and not the right one, I really want to make a note of that and be really conscious about it. And a great way to do that is to keep a little journal of the bugs you make. It's humbling and fascinating, and it will accelerate your recognizing what are the things that you forget. Because everyone has bugs. Without bugs, programming is just a fancy form of typing. So we're all going to make bugs, but keeping a journal can help you be self-aware about what are the missteps that you commonly step into. But team, that's what I have for you tonight. I hope there were some helpful things there.